Okay, 2016 AIME 1, question 6, and full disclosure on this one actually gave me a lot of trouble, so I did read through a solution, and I actually finished it off very similarly to how that solution did. A lot of good solutions are on a website called Art of Problem Solving. If you look it up, lots of great information there for these things. But here's the explanation. So, lots and lots of stuff. In triangle ABC, let I be the in-center, and let the bisector that intersects AB at L, intersects the circumscribed circle at C and D, LI and LD equal 2 and 3 respectively, and then IC will be P over Q, where P and Q are relatively prime integers. Find P plus Q. Okay, so let's take a little time and try to draw this, and then I'm actually going to flip to a second slide that has it already drawn, so I can work with a nice diagram instead of the sloppy mess I'm going to get here. This one would sort of require almost a full page of scratch paper to really just draw the diagram and label things correctly. So I'll start off with my triangle, ABC. So I'll make that A, make that B, make that C. And then I have this inscribed circle, so I'll call that I for the in-center, and I have this inscribed circle. And then I have a circumscribed circle, so let's see, that's going to look something like this. And then we have the angle bisector from C, which will go through the in-center and all the way to the other side, and they tell us that it intersects AB at L and intersects the circumscribed circle at C and D. And finally, so let me put I back up here so you can see it. I kind of wrote over it. They tell us that LI is 2 and LD is 3. Now, one more thing that I'm going to add in, I'm going to put in the other two angle bisectors, because the intersection of the angle bisectors will be the in-center of the circle. And since this is an angle bisector, if this is A, these are both going to be, I'll say alpha, they'll both be the same. If this is B, I'll call both of these beta. And this is C, I'll call both of these gamma. And so this is the diagram I'm going to start with. And I'm going to actually use some similar triangles with this. So there's my ugly diagram. I made a much larger one when I solved it out by hand after I saw how to get through it from the solution. There's a much nicer drawing so you can look at things and not have a mess. Okay, so in here we know that we have 2 here and we have 3 here. The first thing to notice is we actually have some isosceles triangles, and here's why. This angle here and this angle here subtend the same arc, subtend this minor arc CB, and they're both inscribed angles, which means that if this is 2 alpha here, then this is 2 alpha there. So let me put that in. The same exact thing happens with this arc here and this arc here. I'm sorry, this angle here and this angle here with arc AC. So this angle here is 2 beta, which means this one here also has to be 2 beta. Now I actually don't need both of those. I can get around it by only doing one of them, but it does work either way, so either one will work. Alright, what that does for me is this. So this is 2 beta. This here will be alpha plus gamma because we have the exterior angle theorem. We have a triangle. And an exterior angle right here, the exterior angle is the sum of the alternate to, or the opposite to, but distant to interior angles. And that would make sense. This plus this equals 180. So this equals 180 minus this, which will be alpha plus gamma. So I put that in here. So that's going to be alpha plus gamma. And similarly, this here will be beta plus gamma. And now I know from this large triangle ABC, that 2 alpha plus 2 beta plus 2 gamma will equal 180 degrees. And that means that, well, I have 2 alpha in, well, let's consider this triangle here. I draw that in. I have 2 alpha, I have 2 beta, and I have 1 gamma, which means this here has to be gamma. In this triangle here, I have 2 beta plus 2 alpha plus gamma and an unknown equaling 180, so this has to be gamma. And now we can see, so let me switch colors yet again, this triangle here is isosceles, with one of these legs being 5, the other one will have to be 5. This triangle here is also isosceles. And if you didn't catch why in that last thing, it's because the 2 base angles, this is alpha plus gamma, this is alpha plus gamma, so these 2 sides must be congruent. This has length 5, so this also has length 5. And the last piece to all of this, I'm actually going to leave these triangles shaded. I have this triangle, and I could have used the one up here. Again, I told you I only really needed one of them. I don't really need this. And this triangle are similar. Either you can see 2 alpha to 2 alpha, gamma to gamma. You even have this. You have extra information, which means that if this is in a ratio 5 to 3, this is in a ratio 5x to 3x. And from the angle bisector theorem, we have, and I'll write it out in letters, we have CI over IL must equal AC over AL. CI is what we are trying to find. I guess IC, same thing. IL we were given as 2. All right, this is IC because that's what we have over here. So we have IC over 2 equals, and we don't know AC and AL, but I know they'll be in the ratio 5 to 3. So I could put a 5x to 3x, or I could even say this is the ratio AC to AL, so I could just put 5 to 3. And to solve for IC, just multiply both sides by 2. So IC will equal 10/3. Finding P plus Q, 10 plus 3 is 13. So feel free to ask questions. It's a big old mess, but there's the solution to number 6.